Hi, I'd like to take a moment to walk you through the Tri-Sen Tetrasentry, an API 612 compliant trip block for rotating equipment, as well as some of the changes in API, including basic and enhanced recommendations. The August 2014 revision of API has been updated to recognize increased safety and reliability with the change of the design of the solenoid valve configuration. In the past, API required 2 valves in series, as shown here. It becomes quickly apparent if one of the solenoid valve fails stuck, the user will experience a critical equipment failure, whereby the hydraulic trip path may become blocked. The updated API moves to a parallel configuration, shown here, allowing for improved safety, but leaving the user exposed to nuisance trips. Section 12 has added an enhancement to the reliability through a 2 out of 3 recommendation, or a 2 out of 2 taken twice as shown here, where no single failure can prevent the unit from tripping, and no single failure would cause a spurious trip. API has also recognized the high temperature applications that are common for trip mechanisms by updating the insulation class from F to H. We asked ourselves, if we were to design a fast, easy to maintain, and safe trip block, what would it look like? The market feedback we received led to the design of the Tetrasentry, which meets or exceeds the minimum and enhanced API 612 requirements. With the use of 2 series set of parallel solenoid valves, as shown here, there is redundancy in both the ability to trip when necessary and guarding against spurious trips, while allowing the user to run an extended period of time without needing to service the equipment. API 612 recommends regular testing as part of the 2014 enhancements. Testing is enabled via the use of carefully placed orifices and pressure transmitters, as shown here. By de-energizing one solenoid at a time and monitoring the pressure, a predetermined threshold of acceptable response can be observed. This threshold can speak to the fitness of service for all critical equipment, including the status of filters, master solenoid valves, slave pilot sections, isolation valves, orifices, and other equipment. Should a component be found deficient and require service, isolation ball valves can be provided on the drain and supply side, allowing service on any critical equipment without the need to bring the equipment offline or impair the ability of the system to trip. Conveniently placed and compact diagnostic transmitters are available to address the critical equipment recommendations in API. A consolidation manifold is available to serve as a hydraulic marshalling point. Flexible hydraulic interfaces such as ASME B16.5, Code 61, or SAE O-ring boss interfaces are provided. This manifold also serves as a convenient place for the customer's trip header connection orifice. This is an example of a fully configured Tetrasentry. The flexible design allows the isolation valves and other components such as pressure transmitters to be mounted remotely, making the Tetrasentry a very compact and flexible design. The core components are approximately the footprint of a small picnic basket. If you would like more information, please visit our website at www.tri-sen.com or contact one of our global offices or a local Tri-Sen distributor.